Welcome back to our channel. Today we're diving into a fascinating update on one of the most iconic figures in the study of human evolution, Lucy, the ancient hominid. Let's break down what the New York Times has shared about the latest research on Lucy. Lucy was petite, roughly the size of a second-grade student, standing at about 1.2 meters tall, and yet she was remarkably strong. This insight comes from her famous 18-million-year-old fossil known as AL-288-1. Researchers believe that to develop such strong arm bones, Lucy, and possibly her peers, spent a considerable amount of time in trees. This theory is supported by a study published in PLOS One. Discovered nearly half a century ago, Lucy's skeleton was the most complete of the ancient hominids ever found, revolutionizing our understanding of human evolution. There's been some debate over whether Lucy walked on two legs like modern humans, or if she climbed trees to sleep, avoid predators, or gather food. Some scientists involved in this research think she died after falling from a tree, but how much time she spent in trees remains a subject of debate due to different interpretations of her ancient skeletal remains. For the latest study, researchers examined how daily activities might strengthen or weaken bones. By analyzing the internal structure of Lucy's hand and upper right foot bones and comparing them with those of about 100 chimpanzees and 1,000 modern humans, they concluded that climbing trees was part of her daily activities. Her limb strength ratio was more similar to chimpanzees than to modern humans. Doesn't mean she behaved like a chimpanzee, just that her limbs were more chimpanzee-like than modern human, said Christopher Ruff, a paleontologist-anthropologist at Johns Hopkins University who led the study. To reach their conclusions about how Lucy's bones were used in daily life, researchers analyzed 3D digital models of the bones created from scans of the fossils. Bones, like drinking straws, are hollow, and slicing them horizontally reveals a set of bone rings. The width of each ring indicates strength, known as cortical thickness. For example, a professional tennis player's arm bone would have a greater cortical thickness than their other arm. Lucy's bones were quite thick. She was small, but for her size, she was very strong, said John Kappelman, a paleontologist-anthropologist at the University of Texas at Austin, who was involved in the study. As for Lucy's skeletal evidence, it's challenging to prove anything definitively. It's not even 100% certain that Lucy was female. Some suggest Lucy lived around 3.2 million years ago, but accurately dating the skeleton is difficult since it was discovered decades before modern dating methods were developed. The assumption that she's a transitional form is based on the small brain volume inferred from the skull fragments. But this is speculative. Some even suggest she might have been a small child, given the small brain volume. The claim that Lucy changed our understanding of human evolution hinges on the assumption that bipedalism, walking on two legs, occurred before an increase in brain size, contrasting with earlier beliefs. However, the debate over whether Lucy walked upright or climbed trees remains. Despite the ongoing debate, Lucy's discovery has been pivotal in the study of human evolution, though some argue about the extent of her contribution. So, what do you think about these new findings on Lucy? Drop your thoughts in the comments below, and if you found this video enlightening, don't forget to like, share, and subscribe for more fascinating updates on our ancient past. See you in the next video!